Good morning. I am Dr.D.Sathya, working as an assistant professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss about flame photometry. So what is flame photometry? Flame photometry is also one of the analytical technique. So in spectroscopy, we are using some basic spectroscopy, UV visible and IR and atomic absorption spectroscopy and all. In same way, flame photometry also the analytical technique. It's very used for the concentration of metal ions. The metal ions like sodium, potassium, calcium, lithium. So these are the metal ions we can calculate it by using flame photometry. So how do we calculate the metal ions? Because the flame colors will be the different from every metal ions. That means sodium it form the yellow flame, and potassium we can form the violet flame, and calcium orange red flame. So the observing the color of the light they emit in the flame. So this is called the metal ion will be we can detect it. So the observing light of the color of the light they can emit in the flame. The sample solution with the using the burner, the solution flame will be emitted. So the flame color we can see it. So what is the color present? We can calculate the metal ion. What are the metal ions as present in the solution? So the different metals give the different flame of the colors. So what is the principle of flame photometry? So simple thing, it's a atomic emission. Already we have discussed what is the absorption, what is the emission. The absorption means the solution absorbs the light. That means the electrons will be jump into ground state to excited state. When emission of the spectrum, the excited state, the electrons will be jump into the coming into the ground state. This is the emission. So the sample into the flame, the liquid sample enter into the hot flame. So the heat energy excited the atoms. So they move into the higher energy level. So the light emitted, excited atoms emit some specific light. Each element has the unique wavelength. So the light intensity, so the element concentration. This is the flame photometer on simple diagram. So the instrumentation of nebulizer and flame burner, optical filter, detector, digital display. So what is the nebulizer? Why nebulizer is used? It's a converted sample into the mist, some homogeneous mist. Homogeneous means in the similar matter. That means the same pathway is looking like a mist and will be the burner. Again the heat will be emitted, the excited atoms, and select some specific wavelength. The detector will be measure the intensity. So the sample is the first step, nebulizer and filter, and finally display. We are using here the same way like UV, monochromator, detector, amplifier and recorder. Monochromator will be the selected the particular wavelength. In UV visible spectrophotometry also we are discussed. Monochromator is works for particular, it's a select for particular wavelength. The light will be, the beam of light will be passed and different wavelength. The monochromator will be the select the particular wavelength of the solution. So that's why we are using the monochromator. And the detector. Detector, the selected radiation falls into the detector. It's a converter light energy into the electrical signal. And amplifier and recorder. It will be record, displays final the output. So this is a solution. So simple technique how to the process the flame photometry process. The sample solution, then evaporation occurs. Evaporation, after that the vaporization. When vaporization the flame will be affect the heat. Then finally excited atom, detector. So one of the example, the estimation of sodium by flame photometry. So how to the estimate of sodium by flame photometry procedure? First of all, the instrument switch on the regulate the air and gas supply. We can check the how to the air gas supply we can regulate, and first pass the distilled water. We can add the distilled water, set the 0 degree reading, and warm up the instrument for 10 minutes. Already we can on the instrument and warm up for 10 minutes. Set the particular wavelength 589 nanometer, because the sodium for emit the yellow emission. So yellow means we can know about the wavelength. So 589 nanometer, and prepare some standard sodium chloride solution 1 to 10 ppm. ppm means parts per million, and each solution record the some intensity of emitted intensity. The finally flat will be the calibration curve, that means the concentration and intensity, same procedure like a U visible spectra. And the straight line graph helps to determine the unknown sodium concentration. So these are the application of flame photometry: clinical, environmental, and agriculture and food beverages. The lot of very things are used in flame photometry. This is advantages: simple and additive free, suitable for analysis of sodium, and wide range concentration can be determined. Some also disadvantages: limited to alkali and alkaline earth metals only. So we can't go for other metals. High level metals is only for alkali and alkaline earth metal. So load sensitivity compared to the advanced technique, and flame instability is affect some accuracy and repeatability. It's not suitable for non-metal elements, some carbon, nitrogen, and all non-metal elements. This is some questions. So we are discussed what are the working and applications of flame photometry. Thank you.